What's your main gross in C++? Mostly the standard library. Also like templates. Also like it's overly complex. It just feels like there's just so much stuff you got to do. Just like writing a container in C++ is hard. Right? And it's like stupid that it shouldn't be hard, right? If I want to do like my vector. Wait, hold on. Let's actually try to do it. Let's actually try to do it. Just to demonstrate how fucking stupid this language is. Okay, so say I want to make like some vector, right? It's been a while, so excuse my absolute fucking disaster here. How do you int main? How do you write this language? Return 0. All right, yeah, okay. So say we want to make a vector. So what do you got to do here? You're gonna have some sort of like I guess this is how you would do it, right? Let's pretend for now. Well, let's maybe write something a little bit more simple. Stack vector. We'll do that because that's easy to write. So we're gonna have probably what you write like int here size, I think. Size t size. Is that how you do this? Then you have Jesus. Size? Is that how you write this in this language? Int x4. Yeah, that sounds right. Stack vector s. Okay. G++. Is that right? We're off. Size t not declared. Like this? Maybe it's to def. Okay. And then here we need to say the type. Dude. Int 32. Which is probably like this. Right. And we'll say that we have 10 of them. Okay. Okay. We're getting somewhere. So even just const my vector snap out of man. Dude, I know. Sorry. Even just trying to write your constructors here sucks, right? You have to write your default constructor. Should we pretend that there's some sort of like cleanup to do here? Maybe we can call this like fixed capacity vector. Yeah, that's probably a nicer example because then we have to do some like memory freeing. Okay. Yeah. So this will instead not take this at compile time. We'll specify the size of this thing at runtime. And he will then say that I'm a T star elms and size T size. Okay. That's how we'll stash this stuff. Array is the name Std uses. But I want it to be growable. I'm like pretending that it's a vector, but like it's got like a upper bound. You know what I mean? Okay. So then we write like our constructor. Excuse my just like lack of memory here. And then we go like what? Here we need to like allocate. Dude, C++ new? How the fuck do you use new in this language? Right, you write like the array. Is it just like new lm size? Is that it? Okay. Yeah. Something like this. New t size. That makes more sense. And then size is size. Okay. I think that's our constructor. Does that compile? Maybe like this. Okay, then he's like, this is private, right? Because this language fucking blows. Struct. All right. So we have our vector. And then let's just make like a simple little push. So push, what, like we push a t. And do we need to like fucking write self anywhere in this language? No, it just comes for free. So we just write like lms at size is equal to val size plus plus. You can even do it here. And then I guess here we have to do something clever, like say like if size is equal, if we need capacity here. Size equals 0, size equals capacity. Boom. Or capacity equals capacity. Okay. This should do what I want. If size equals capacity, throw, stood, runtime, error, fuck. The length of your tabs concerning and triggering me at the same time. I'm just using the defaults, man. Where's runtime error? Where is this? Stood accept. I apologize, guys. I'm rusty. Okay. So now we should be able to be like s push 4, s push 5. And then like what? If we wanted to be able to like iterate this container. If we want it to be like for const auto and x from s stood cout x, right? Say we want to do that. Say we want to do that. Ah, fuck. Well, that's a disaster. Okay, well, partially because we need IOStream, right? Include IOStream. So that solves part 1. But the problem here is now that, like this, we need to write like begin and end things for this. So okay, begin and end for this is probably pretty easy. We can probably return like t star begin. Returns elms, and end probably returns elms plus size, probably. Cannot be overloaded. T star begin. Oh, end. Okay, so that should allow us to run that, I guess. So we get 4 and 5 there. Okay, we're starting to get somewhere. I think that technically, I'm not sure if this is quite right. Usually I think you're supposed to return like an iterator type here, but I think our iterator type is like pretty simple because pointers like happen to fulfill all the constraints that we need. So that's fine. Now where it gets shit is if I now go, oh, I guess we need our destructor. Of course we need our destructor. Fixed capacity vector. He needs to delete elms. Do I have to do it like this? I think I remember there being some sort of rule where like delete in C++, you have different syntax for if it was out new with a, yeah. If it's new as an array, you have a different syntax for if it's new as a single thing. So it's like this? Is that what they fucking want? Really? Okay, cool. Okay, so in this case, say we go fix, like, let's say we want to copy this vector. S2 equals S. Free. Double free detected, right? Fuck. Okay, so if we assign this thing, now we have to make like a special copy constructor, right? A special copy constructor to say, oh, we need to actually allocate a new set of elms and capacity and size and copy all that shit over. Okay, so you have like fixed capacity vector, and he takes another fixed capacity vector, and we copy all the fields over. So we go like, you know, our elms is a new t of other size, capacity probably. Sorry, this is my brain. Then you have, I guess you return, how do you, it's not this, that's Zig. You return, dude. Oh, I guess it's just that, it's just this. Right, elms is this, size equals other size, and capacity equals other capacity. Okay, so that solves that problem. Sometimes you also have to make an assignment operator. I don't remember when. Right? There's another constructor for like for like there's one constructor for like S2S, right? This is like one thing and this is another thing, and sometimes they behave differently. So like, oh, you also need to memcopy the memories. Yeah, that's a really good point. Stud mem copy man 3 mem copy. There we go. So we have desk source size. So it's like elms, other elms, and then other like other size times size of t, I guess, probably something like that. Do I mean w memcopy? No. Is memcopy? God damn it. C string. Okay. Right, and then RCR stun is reminding me of the difference here. So this calls the copy constructor, but if I were to do this, then it would not. Then this calls the so I guess we also want a like a constructor here that doesn't allocate elms and sets the capacity to 0, right? Probably. Null pointer. And then we need a comma here. Okay. So now we have the same problem where we do this equals assignment. It compiles for some fucking reason and then double freeze. So then we're like, okay, I guess we need an assignment operator. So then we do like fixed capacity vector and I think is the syntax here. He's like a reference to this thing. Operator equals takes like another other one of these things. And then like in here, what do we have to do? We have to just like probably do like the same fucking shit, right? So that should be fine. Okay, and then we have to return this for this to be like correct. This star this. Okay, there we go. We're back to fucking. We're fucking compiling again. We're fucking compiling again. It compiles because you have a defaulted operator equals that doesn't memcopy between stocks. Yeah, I know. And then so now we have these, but now what happens? Now what happens if I do s2 is equal to std move s, right? What happens if we do that? Shockingly, I expected that to double free. Oh, it's probably that if I want moves to work, I think that the move constructor and the move assignment operator just don't work unless you manually define them. But say that you wanted to be able to say like, okay, like this thing used to be S, now I want it to be S2, and like S is now like invalid, and so like I don't want to allocate new memory and copy it every time. Well, I guess we'll fucking write a move constructor then. So then you go like this, and you copy this guy, and you go, okay, instead of writing const here, I'm gonna put 2 ampersands. Who the fuck knows what that means? I mean, I know what it means, but like who the fuck knows what the double ampersand means? Because like it means different things in different contexts, right? If you use it in a template, it's like it does something completely different than if you use it in a regular context, I think, if my memory serves correctly. So you have to be really careful with that. But in this context, it means this thing's an R value reference, which means it's like a thing that doesn't have like a name. But like if you write std move, you can convert a thing that does have a name into something that doesn't have a name. It's basically to say like this was a temporary value, but you can treat things that aren't temporary values like they're temporary values. Because if it's a temporary value, you probably want to move out of it instead of copy out of it, right? Just like, sure. So here, we don't have to do anything. We just say like elms is equal to other elms, right? Size equal to other size. And capacity is equal to other capacity. Hell yeah. Okay, cool. So that seems great. Does this compile and work now? Sure. Looks like it does. Now, I don't really remember the rules, but there's also a move assignment operator where you want to do the same thing, but I don't really remember why this is different than that. I don't remember. Move constructor versus move assignment. What the fuck is the difference? I don't fucking remember. Oh, okay, sure. So these are just two different things, right? So we're in the assignment case. What if we wanted to do S2 is equal to stood move S? Sorry, S3, I guess. And I guess we move S2 now. Oh, double free again. Uh-oh, that sucks. Oh, and it's because it's actually using the copy constructor. It's not like oh, you don't have a move constructor, fuck you. It's like, oh, you will just use the copy constructor. Oh, actually no, wait, maybe the lie here is because here I have to no, I'm a liar. Here we have to set other dot elms to null pointer and other capacity equals 0. And then here we have to say like if elms is equal to null pointer, we do nothing or something. That might be the problem. Oh yeah, that is. Okay. So that means that probably this guy is doing a copy, even though we think it's doing a move. That's probably the problem, actually. So here, I bet you if we were to stood cout construct, and here we would be like copy construct, and here we say copy assign, and here we go move construct. You do this, and it actually turns out that this here is a copy assignment, even though or this is a move constructor, this is a copy assignment, even though you'd think it's not. So we thought we're trying to fucking move the stuff, but we can't. Uh-oh, it's because we've got to write the fucking move assignment operator. So I guess we'll write one of those. So we take the fucking, take this and we put another ampersand in here, and then I guess we kind of copy the fucking implementation of this guy. And I think that there's some like clever way that you can like make your move assignment and move constructor the same, but like it's not really trivial. You have to do some sort of like construct a thing and then swap it into this or something. And then even then it doesn't really like work quite right all the time. Probably other size equals 0 2. Return this. Okay, so now stood cout move assignment. Okay, cool. So we finally fucking got like a class where you can copy, where you can just do assignments, right? We're just assigning stuff. And it's just like, look how much fucking garbage we had to write to just like assign shit. And it's like, I get it. I'm not doing it like the optimal way, but it's just like, how the fuck? How the fuck are you supposed to like do this reasonably? We haven't even gotten into the fact that like as soon as you start trying to like do anything based off the template argument, you just get like fucked. You have to do all of this like bullshit, like you write like a separate language in this like templated, like it's just garbage. It's just so frustrating to work. Like when I write C, I feel like when I do something wrong, it's my fault, right? I'm like, I should have done better. And I'm okay with that, right? I'm okay with like the idea that I didn't do what I wanted to do. But in C++, even if you just take out bullshit of the standard library, just trying to use the language to do something like write a container is just like, what the fuck are we doing? We're just fighting. I'm just fighting the language. And it's like, the idea of move constructors is like, yeah, okay, like it makes sense, right? Because like move constructors, like sometimes you don't want to copy and then free the other memory again. So like they make sense, but it just results in all this complexity. And so like this is kind of why I like a language like Zig, and why I kind of say like I'm not the biggest fan of what people call RAII. I'm not really convinced that RAII is like a reasonable name for this. I feel like RAII just means you have destructors. But here, I mean, they basically mean, they call it resource acquisition is initialization, and they just mean like you have constructors and destructors, I think. But like this is like the type of complexity that it can cause. I don't know how in Rust it doesn't cause this complexity. You have like the drop trait. I guess in Rust you don't have copy constructors. Everything is a move by default, and then you have to write explicit clone methods, which maybe is like a little bit better. I'm not experienced enough in other languages, but it feels like you want it feels like you want control of this stuff. You need to write it somewhere. Might as well do it in the class. And once you're done with that, it's feasible in class-size code. At least it gets you something. It's if the trade-off is worth it is not a question. Yeah, I think that like I'm not against necessarily having move and copy constructors. What I'm against is like the complete silence and unexpected behavior at every step. I think that's what I'm against, right? If the language said like if like the assignment operator came out of the constructor for free and you had to write them or explicitly opt into them, I think it's a lot better. But I don't know, like it's just there's so many ways to get it wrong by mistake, and that pisses me off. Every construction should be deleted by default. That's kind of how I feel. I feel like that would make it a lot better. Okay, yeah, and then like we haven't gotten onto all this stuff where like, so I wrote my push function. We can't error on this for backwards compatibility. This is my main gripe. That makes sense. Okay, so like then like we haven't gotten to the fact that this push function, this is kind of bad. This is wrong actually. I mean, it's not like really wrong, but I should have written like I should have probably written t and here, right? Because like what if val is like what if our templated type isn't like an integer, but it's like a complex type? And so if we're like moving a complex type into our vector of things, then like we don't want to run its destructor externally. We want to run we want to only run the destructor here. We want to move the thing in or something, right? But then like maybe somebody doesn't want to move it in, and so like maybe you actually are supposed to do this because C++ has like temporary it like C++ will resolve this automatically, I believe. I think that if you write t and, that's really bad because it will always run the copy constructor. But if you write t here or t and, well, if you write t and, then you have to pass it an r value reference, I think. So it means you have to type std move. But if you write t val, then it kind of will do the right thing by default automatically, I think. If you write std move here, which we didn't. Right? So it's just like there's just so many things, so many small details to think about that are just like it's just frustrating. It's just frustrating. Right? So that's why I don't like writing it. And this is just like one example. The whole language is like this, right? The whole standard library is just like full of this bullshit. Like the standard library has like embraced template metaprogramming, which is like it's just its own fucking confusing language. Instead of being like if thing, you write like template class t and you write like is true. But you're like bool is true equals true, and then like you overload this for I think you have to write the class name. So like is t bool like int, right? If we wanted to write this, you would go like you overload this for t or for int, I think, and then you put like like bool is true if it const expr bool maybe, and then I guess you default this to false for everything else. So then you write like false. Maybe you write value here is what this is the typical thing. Yeah, it's something like this, and then you write like there's some way to do like is t int v. I don't remember how to do this. Like template there's a way to like forward this into like a value, and then you can write like in here like is t int value, and it's like well, like why are we doing this? Why are we fucking doing this? Oh, using. Yeah, that sounds right. Template type name t using is t int v equals is t int t value or something. Is that how you do this? Yeah, it's something like this. Can we write like unsigned int? He's mad because value declared as const expr. Am I doing this wrong? I thought it was this. Static? Yeah. Right, I have to write type name here now, because, like, why the fuck not? And then names this, which is not a type. I thought this was it. We can look. Is, like, C++, is there, like, CPP typesetter, I think, is where this stuff is? Is it, where the fuck is most of the bullshit in here? Type traits? Yeah, okay. So, like, is class. So then they define const expr bool. Const expr bool. Okay, and then 18. Wait, why? What have I done wrong here? Okay, here we go. So we finally got there. So, like, this is how you do, like, type stuff, where you're like, if I want to, like, like inspect the type in some way, you do this. And so then, like, if you wanted to do this for, like, all integer types, you overload this for, like, unsigned int and, like, long. And it's just like, what are we doing? Right? Like, couldn't we have just written a language where you could type, like, if and then the types? Right? Wouldn't that have been way better? And it's just like, I don't know, man. And it's like, yeah, you can choose not to use this stuff, but it's like, I don't know. Sometimes you want to write a generic type and, like, do stuff based off of the thing it is. I don't know, man. It's like and the feature is there and used heavily in the standard library. And it's just like, I don't know, man. I don't know. This language is shit.